Hey everybody, I'm Matthieu from RealSense Inc. and I have with me my good friend Borja Cornado from CFZ Cobots. Hey Borja, how are you, sir?
Fine. Thank you very much, Chris, for having me with you here today. Thank you.
Awesome. Well, tell us about yourself. I met you at Automatica. You were doing really cool things. So tell us about yourself.
Okay, I am in the industrial automation business since more than 35 years ago. I started programming PLCs, and now we are dealing with robots and having fun putting eyes to the robots.
Well,
We're
I
very
tell you,
busy.
your demo was really impressive. You had this mechanical arm that was moving, grabbing things while they were moving. It was quite amazing. So tell us a little bit. What does CFZ Cobots do? What's the company do?
Okay, our company was founded in 1997 as an industrial automation company, and in 2016 we started with robotics, especially with Cobots, which is collaborative robots. We split the company and we created a CFZ, and we are selling robots, but now more and more focused in developing solutions for guidance of robots in a 3D world. This is what we are doing now with many different brands of robots, and it's a challenge to grab milliseconds to the time of all the process.
Well, and the world's dynamic. The world's not clean and structured. Like things are moving, different things are moving. Robots need to adapt, right?
Yes, we saw it from the very beginning. When we started with robots, we saw that different things. We saw that people in factories in the floor, they don't want to program robots. They don't want to spend time doing it, or maybe they don't even know how to do it. But they need. Why? Because they need to change production. They need to change formats. Now in a regular mid-size enterprise, I'm talking about small companies. They may change twice a day what they're producing. So there are many problems of what it costs to all the mechanics to adjust the changes of production, and we saw that with 3D vision we could solve many of them. Moreover, robotic cells used to be very expensive, and there was a need to drop the price. So many companies were able to buy a complete automation solution. So that led us to the point that where vision was the only solution to combine all the problems and all the solutions.
Can you tell us a little bit about some of your customers and what are they doing with your technologies?
Yes, many. We are located in Spain, and we are located in an area where we have automotive industry, a lot of tier ones or tier twos. We even have an OEM, and we have a Ford Motor Company plant here in Valencia. We have plastic industry, we have metal industry, we have food and beverage, a lot of agriculture industry. It's kind of mixture.
The,
And all of them have one thing in common. They are facing labor shortage. It's a sheer reality, and they need to install robots.
well, I liked your point too. And when you consider the impact of labor shortage, training these robots to do something specific is also a challenge. Where it seems like you've found a way to make this easier and adaptive in for industrial solutions.
Yes, we were lucky. We were lucky because after playing with the camera, with the coordinates, and all the technology things underlying the final solution, we were lucky because, as I told you, people do not have the time to program and do not have the train objects. So 1 year and a half ago, maybe 2 years ago now, Meta launched SAM, Segment Anything Model, as a foundation model, which is capable for medical applications, many different applications, and also for industrial. So, which means in our world, it means that we can see a scene which the robot has never seen it before. And we have the ability to segment objects, which means we are capable of distinguish one object very close to the next object. We don't have to spend a lot of money with mechanical features to separate the objects. So when we combine 2D vision with segmentation and the point cloud of a 3D camera, we can orientate the robot to grab an object who has never seen before, just like you and I are doing when we are picking objects or anything.
Yeah, it's like the human brain doesn't.
Amazing.
Yeah, we don't even think about what we're doing, right? You grab that bolt, and you could easily say the difference between two bolts, etc., right?
And this is how we got into the RealSense world, because your cameras combine the 2D scene, the 2D image, with the point cloud with a very small form factor, which means you can place the camera without interfering with the gripper or with the rest of the robot parts.
And do you have the RealSense camera on the gripper, like near the arm, or where are you putting the RealSense camera in your solution?
We put the system integrator. They define the type of robot they need, and of course the type of gripper they need. And once the gripper is defined, we place the little tiny camera whenever it fits best.
Yep.
We don't require a special mounting location. We have a calibration plate. We put the camera, and then afterwards we calibrate the whole system, and that's it. Start moving.
You make it sound really simple.
This is the point. Because it's like telephone. It's like mobile phones. You don't read the manual. You don't never read the manual. You just buy it and start using it. This is the approach. This is what the market needs.
So tell us maybe a little bit about using RealSense. Was the integration as simple as you make it sound for the operations?
Yes, RealSense has a real stable SDK with a lot of documentation, and that made it very easy for us to get the information from the camera, to combine it with the information of the robot to make a solution. There are different models. And for us, what really made a difference is when a partner of RealSense, they made a solution with industrial enclosure. Not especially for the fact that the enclosure was more protected against dust or water or whatever, but for the point that it had Ethernet interface. You know why? The reason is that robots are moving, and the cable have torsion, a lot of torsion. And there are many manufacturers of Ethernet cable protected against torsion. With USB, it was more difficult to find an industrial solution, but that made a difference for us.
Yeah, and USB is just finicky. Like from my experiences with it, like the hub stops, communicating. You've got to reboot things with power over Ethernet, and even like the MIPI FACRA type solutions. You're right. They're industrial. They're made for that type of contortions and pressure and longevity. Resilience is what I'm trying to say.
Yes, longevity, because the robots are intended to work 24 hours, 7 days a week. So it's important all the components are resilient and tough enough.
So you're reading my mind. So I mean, I loved watching your demo. We'll include a demo of your technology in this interview video. But like, what would you say is super secret? Like what is the super secret sauce to what you guys do?
I think that our main point is that we are very fast with a zero shot solution. Zero shot, which means we don't have to train the object. Right now, we are in 500 milliseconds. We are fighting every day against the stopwatch. By the end of the year, we'll be in the point of 300 milliseconds. From the point where the robot is ready to grab an object until the moment it starts moving, which means we have to trigger the camera, get the image, do all the processing, all the computing in the IPC, and then send back the robot the point in the space to move. And 0.3 seconds, which is 300 milliseconds, it's a very good time, very good time, very, very, very good.
That's an
It's
important.
almost real time.
Yeah, I was going to say that because I think that's an important number from like when I hear people's perception of things, like to consider things real time. It's right around that 300 millisecond time frame where humans don't notice latency. So if it takes a human that long to recognize something and then decide to reach for it, your technology is basically doing
Yes,
the same
really,
thing.
it's not really a matter of perception, but it's a matter of how much money does time cost. I mean, production. We don't need to. A robot are not intended to be stand still. They are intended to be moving all the time. So this is the point. We don't have the opportunity to spend 2 seconds or 3 seconds analyzing the scene and computing and everything because that costs a lot of money. This is the point.
Yep. That's an important point to even talk about too, because with like the RealSense cameras now doing things like 90 frames per second, I think we're surpassing human perception and accuracy, within this new digital world of robotics and for your platforms to be, like you said, fighting the stopwatch, every day, trying to make things faster. Like soon, these robotic solutions will outpace humans. Like we talk 24/7, but just on the regular capacity of the job, like even faster, more accurate.
Yes, and also you have to think that a human worker is working very fast when the boss is behind looking at what he's doing. It's always the same story. But it's not possible to keep a pace of working really hard, 8 hours. I mean, it's just impossible. And the average is what counts, and the robot is keeping the same average.
Well, I tell you, it was awesome to see your demo. We'll put that in this interview here following this conversation, and it's always a pleasure to meet with you and see what you're up to next. And I can't wait to see the next evolution of your technology.
Okay.
Well,
Yes.
thank you so much, Borja, for joining me on this call, and I'm sure we'll do a deeper dive on a follow up call more about your technology and RealSense use.
Okay, Chris. Thank you very much for your time. It was a pleasure being here with you today.
Oh, the pleasure's all mine. Thank you so much, and keep fighting that stopwatch. Make it go faster.
Okay. Bye
Cool.
bye.
Bye. Thank you.